The concept of graphing parabolas. The focus on this video would be graphing a standard parabola. With a standard parabola, you're going to have standard movements. Example of what I'm referring to. I'm just going to generically throw it right in on the middle of my paper, not even graph paper. If I know where my vertex is, we'll call this my vertex. I know that once I've identified the placement of my vertex and I have a standard movement, I'm referring to something like this. Y equals x minus 2 quantity squared plus 5. If I can find that vertex at 2, 5, which I'm just throwing in random space, I'm just saying it's right here. I know to find other lattice points. If you forget what a lattice point it means integer values on a coordinate plane. To find other integer values, I just have to follow these standard movements. From the vertex, I can go right 1. If you square 1, you go up 1. I can also go left 1. Negative 1 squared is 1. The first movement would be right or left 1, up 1. Those are standard movements. 1, 1. If I were to move 2 units right or left, so I go 1, 2. 2 squared is 4. 1, 2, 3, 4. 2 units to the left, 1, 2, 3, 4, which means I can find point 1, 2, 3, 4, and 5. There's 5 nice points for a parabola. And for argument's sake, let's say we went 3 units out. To go 3 units from the vertex, it's almost like graphing from the origin. Everything comes from that vertex. Everything is defined from that vertex when graphing in this way. So I go 3 units to the right, 3 units to the left. If you square 3, I should be going up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You always have these sister points. 1, 2, 3, 4, 5, 6, 7, 8, 9. And when I put my X's there, you see I can connect all those points and I get a pretty good picture of a parabola. Now, I want to go through specific examples, and I'm just going to keep using this concept of right or left 1, up 1, right or left 2, up 2, right or left 3, up 9. And I'll show you how this is actually employed when graphing parabolas. It'll make you very quick, and it gives you very accurate points to graph parabolas. So let's look at a couple examples. My first example here, I've got y is equal to x minus 2 quantity squared plus 1. This is a standard opening because a is 1, and I've got this vertex that would be found at 2, 1. So I locate 2, 1, I put a point. And the objective is to graph as many points on this grid as I can. So once I have the vertex, I can go right 1, up 1, left 1, up 1, right 2, up 1, 2, 3, 4, left 2, up 1, 2, 3, 4. Again, see what I mean by sister points. If I get 1 here, I know I'm going to have 1 there. And then I'm not going to be able to go 3 because I'm not going to get 9 points on this grid. But I've got those 5, and sometimes 5 will do it for us. We know it's just going to look something like that. That's a standard parabola. I'm just going to keep rolling with this. For the second example, I've got y equal x plus 3 quantity squared minus 5. I have a vertex that would be negative 3, negative 5. So I can locate negative 3, negative 5. There's my point. Now I'm just going to have my standard movements. Right or left 1, up 1. If I go right or left 2 from the vertex, I should go up 4. So it's 1, 2, 3, 4. And once again, there should be a sister point. So they're pretty easy to graph once you get the hang of this. I will be able to do a third movement on this one. So I'm going to go 1, 2, 3 to the right. That should take me up 9. There's 5, 6, 7, 8, 9. If I go another unit to the left, that would take me up 9. And then I can simply connect all of those points. That is your standard parabola or parabolic movements. Let's do a couple more. On this paper I have a few of these that have negatives. So these are going to open downward because the A values are negative. The process doesn't change. I'm simply going to find my vertex at negative 4, 6. I've got a vertex at negative 4, 6. Opposite of what's in parentheses. Keep what's on the outside. So I go to negative 4, up 6, 1, 2, 3, 4, 5, 6. And then everything starts from there. It's basically a giant phase shift. So on this one, instead of going up, because of that negative, it just tells me I'm going to go downward. So I go right or left 1, down 1, left, down 1. If I go 2 to the right, I should go down 4. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, because I have those sister points. And once again, I think I'll be able to get a third series of these standard movements. If I go right 3 units, I should be able to go down 9. And there should be a sister point to this, meaning that if I just bump over 1 unit, there should be the other point to go along with that. I connect my dots. There's a standard parabola that's opening downward. Let's do another. At this one, I have a vertex at 1, 2. So I've got a vertex at 1, 2, opposite of what's in the parenthesis. Keep what's on the outside. I locate 1, 2. Because the A value is negative 1, I know it's standard and it's going to open downward. So I can go right 1 unit, down 1. Left 1 unit, down 1 from the vertex. Right 2, down 1, 2, 3, 4. Likewise, left 2, down 4. I think I'm just going to barely be able to get that on there. I can go a third movement here, 3 units to the right. I should go all the way down 9 units. 3 to the left, 9 down. And then we connect those dots. As I connect those dots, here's a standard parabola that's opening downward. So there's 4 examples of how to graph our standard parabola. I'm not talking standard form, I'm talking when the A is 1. So it's a standard, it's standard form and it's a standard opening. That's what you most often see when graphing these. So 4 examples of standard parabolas with standard openings.